Welcome everyone. Today we're going to talk about friction, which is a contact force that arises between two objects that is parallel to their surface of contact. In particular, we're going to start by talking about a particular kind of friction called static friction, which is where two objects are trying to move apart from each other, but in which they stay with the same relative motion. So I'm trying to push these books apart, but they are not sliding relative to each other. And the thing that is keeping them from sliding, no matter how hard I push, is called static friction. Static friction we will typically represent with our regular symbol F for the force, and then a superscript SF. And of course, you'd put your usual objects down here. Here we might think about the static friction force on book 1 by book 2, for example. And we can actually develop a quantitative model for how static friction works. Like any other force, the static friction force is a vector, which means I care both about its direction and its magnitude. So for the magnitude, all I can say is that the static friction force is less than or equal to something called the coefficient of static friction, which we will symbolize with the Greek letter lowercase mu. And then you'll put an SF, or sometimes just an S subscript on here, times the normal force that is acting on the same objects, so between objects 1 and 2. This equation is only true for the magnitude of the static friction force. So let's do an example here. So here again are my books, book 1 and book 2. So I'm trying to push them apart, which means there is static friction in between them. And the size of that static friction force is not equal to this number, but is less than or equal to it, which means that I can keep having a bigger and bigger friction force, depending on how hard I push, all the way up until I reach whatever this number is. That means that the static friction force could be as low as 0 or as big as whatever this number is, where the normal force has to do with the same interface, so the two books acting on each other. Now the other thing I care about for static friction is the direction, and the direction of the static friction force is always opposite the attempted relative motion. And I emphasize here that this is always attempted relative motion in the case of static friction, because if the objects are actually moving relative to each other, then you don't have static friction anymore. So it's always opposite the direction that the objects are trying to move apart from each other, but in which they're never quite actually able to move.